Hi, in this video I'm going to talk about what is weighted least square regression. You might have heard about what is the ordinary least square regression. This is different from the ordinary least square, commonly known as OLS regressions. So we'll see how it is different and in which all cases you need to use the weighted least square instead of ordinary least square. Well, weighted least square is popularly known as the WLS, and the ordinary least square is known as OLS. So we will understand what the difference is between ordinary least square and weighted least square. The ordinary least square assumes that there is constant variance in the errors. So we have an error term, right? And we assume that the error term in ordinary least square is having a constant variance, okay, and we call that property as homoscedasticity, okay, or we call the error term to be homoscedastic, right? If you're familiar with OLS, I'm sure you would have heard about what homoscedasticity is. So that is one assumption in OLS. The method of weighted least square can be used when ordinary least square assumption of constant variance in the error is violated. Okay, so this is the important point to remember. So you can use WLS in place of OLS when the constant variance assumption is violated. So you cannot use OLS if your error is not homoscedastic, right? In that scenario, you can use the WLS. So now it's clear where exactly what is the fundamental difference between OLS and WLS. Now we'll get into the deeper theory of the differences, and we'll understand how we can make the best use of WLS when we cannot use OLS. Okay. Now the scenario when the error term is not homoscedastic, where it doesn't have a constant variance, we call that as heteroscedasticity, right? So whenever we have the heteroscedasticity, we need to use WLS. Of course, there are other means of getting rid of heteroscedasticity and using homoscedasticity, but one of the way is using WLS instead of OLS. And the model that we're considering is this one, a simple linear regression model where y is the dependent variable, x is the independent variable, and epsilon is the error term, and beta is the set of parameters. Now let's get into a little bit of deeper mathematics. You may not be comfortable with the depth of mathematics involved while explaining the difference between OLS and WLS. I'll just give you a brief overview of how estimation is different in OLS than what we do in WLS. Okay, we all know that epsilon is the error term, and it is assumed to be having a multivariate normal distribution with a mean of 0 and a constant variance, right? Mean of 0 and variance is constant. Okay, now we have this the variance covariance matrix with us. Okay, and this relates to all the observations in your data sets. Now with this in mind, we define what is known as a weight of something. Okay, so weight of something or weight of an observation in your data point is defined like this. Weight is nothing but the reciprocal of its variance. Okay, now the reason we're talking about a particular observation is because each of these error term is associated with a single observation, right? And it differs, like you have error 1, error 2, and so on, right? So we defined weight 1 is 1 by sigma 1 square. Sigma is what we have defined here, right? This is sigma 2, and so on. So this is nothing but the variance of the error terms, right? The covariance, of course, are all 0 for the errors. All right, so